Hello and welcome to this webinar, continuing my monthly series on language features of version 18. There has been a couple of previous webinars. We're doing every other of our webinars in this series. So this is the third installment, and we have been going over all these features that you can see an overview of here. In the previous webinars, we have been going over the new features. You can check out those on dialog.tv/webinar. Today, I'm continuing with improved features, and there are actually so many things in version 18.0 that when we put the list together for our release notes and announcements, we forgot about one, but I'll go through it here as well. So we're going to go through improvements in system functions operators today. And the first one is to quote JSON. So a bit of background. JSON is an excellent and very used data serialization format. However, it has some deficiencies when it comes to representing arrays coming from APL. A main one is that while APL has high-rank arrays, matrices, and so on, JSON, which carries over its array model from JavaScript, only has lists or vectors, list of lists, vectors of vectors, and so on. And that means that in those languages that use this array model, they will represent things like a matrix as a list of lists, whereas in APL we're able to distinguish between the two. Of course, if we are munging data on the APL side, then we will often use a high-rank array. But when we are ready to send off the result out there in the world, then we need to convert it to something that the recipient can understand. And for that, we'll have a look at the improvement done to quote.json. So, if you've ever tried converting to JSON some APL data, then you'll probably run into this. You create, say, a matrix, and you try to convert that to JSON, and you get an error message saying that it couldn't do that. This is, of course, because it has too high rank. There's an easy fix. You apply the split function, and this changes the matrix into a vector of vectors, and that can be mapped into JSON. Not a problem. Until you start doing things with a higher rank. So here is a rank 3 array, and a simple split won't do. Of course, we can split twice, and then we can convert to JSON. But it would be nice if we had a more general approach to this. So what you can do is, we need to split one less time than the rank of the array. So we find the rank of the array, subtract 1, and then we apply split that many times. This also means if you already have a vector, then we don't need to split at all. Same thing goes for a scalar. However, there's a problem with this approach. Your overall data might very well be a vector, and then the rank is 1, subtract 1, we get 0, we don't apply split at all. But there could be elements of the vector that themselves are high rank. And this approach won't, so to say, dig into the data to find elements that are problematic. And so this, we can see that if we try to apply it, we still have a matrix in the first element. You would have to come up with something a whole lot more clever, and possibly also to be considered ugly. This function traverses the array, element by element, and every time it meets something that has a rank that's too high, that's greater than 1, then it's going to split it and continue traversing. And we can see that we apply it, and even the inner matrix got split. But that doesn't solve all the problems. Let's say that this data occurs inside a namespace, which will be converted to a JSON object. Well, clearly, the function starts working and it sees that the namespace is a scalar and returns it as it is. We would in fact have to write some very complex namespace traversing code that went in and changed everything. And being that namespaces are mutable, then it would affect the data that's already in your workspace. So we'd have to start off with making a deep clone of any namespace that we meet on the way, and potentially we could blow up the usage of memory by a lot, having to copy everything. And there are even worse issues. There might be things that we can convert to JSON, but we are not allowed to make a deep clone of. There could be references to various places. So, to solve this problem, instead of you having to write a lot of code to try to fix up things, we supply you now with an option called high rank. Now, JSON is going to traverse any APL array that you throw at it. It has to do that anyway, as it converts it to JSON. But now, anytime it sees something that has high rank, instead of erroring, it's going to split it appropriately and as much as needed until it becomes something it can convert. We can look at what it's going to convert, because when we convert from JSON, then it doesn't matter that we have high rank turned on. It's not going to automatically mix, because data that comes in from the world outside, there's just no way to know for the system whether that was intended as a high rank array or in fact it needed to stay a list of lists. So that's something you have to do in your application depending on how you're going to use what's coming in. So the option is ignored and we're just doing a regular JSON conversion. So what's happening here is that first we convert the data to JSON using the high rank option, and then we convert it back again to APL, and we can see that our matrix became transformed into a vector of vectors. So that's this extension to QuadJSON. The next extension to QuadJSON is actually almost a new language. Now here's the thing. With version 18, something I am not going to address in this series is the addition of cross-platform configuration files. So we were looking around at which kind of configuration file format should we add to Dyalog. Previously, we have been suffering from having all kinds of ways of setting settings. You have environment variables, command line arguments, Windows registry, and even some files that could affect things. We settled on JSON, but with a little bit of modification. JSON is really nice in being treatable by machines, not just readable, but also writable. But when it comes to using JSON as a configuration file format, it has some shortcomings. Mainly that it is quite noisy. Luckily, a group of people have gotten together and they have created something they call JSON 5. It's not the 5th version of JSON. Rather, JSON originally comes as a subset, or intended to be a subset of JavaScript, so the object notation from JavaScript. JavaScript has various standardized versions, and there's a version called ECMAScript 5. By taking a little bit bigger subset of ECMAScript 5 or JavaScript, then we allow writing some settings, some configurations, some objects in a way that's much more friendly to humans. And that's important because configuration files are often modified by humans. Here's a sample configuration file. It's not really meaningful, but it kind of gives the gist of the things you can do in our configuration files. And if we start going through it step by step, we can compare to how we are allowed to express it in JSON 5. Again, JSON 5 is a superset of JSON, so anything that's valid JSON is valid JSON 5 as well. And if you want to stick to strict JSON in a configuration file, that's fine as well. We allow you to use JSON 5 for other purposes, and here's a comparison. So the first thing we see is that when you have a name, so we have an object which corresponds to a namespace, we have these name value pairs. And the name, as long as it's spelled with regular characters, which basically means it's like a valid name in APL. Almost. There are a couple of differences. But normal, sane names, you don't need the quotes around them, and that removes a lot of the noise. There's no ambiguity here. However, if you have a name that is crazy, that is something, and this one doesn't work in APL either, then to keep things clear, we have to remain with the quotes around them. Another nice thing is that JSON 5 adds some additional escapes. So these are ways to express in plain text control characters that you normally wouldn't want to have literally inside your text. So JSON only has this one format using 4 hexadecimal digits preceded by a \u, besides for some very, very common escapes. JSON 5 adds another couple of shorthand escapes, and we'll see in a moment it also has a shorter form, and it has some additional ones I won't go into here, but you can look it up in the documentation for JSON 5. Something really important for configuration files are comments. So in a configuration file, you often want to have a little comment next to a setting saying what kind of change this affects, or you want to temporarily comment out some settings to see what happens, or to show that something is optional. JSON doesn't have comments, and that's because Douglas Crockford, who designed JSON, the JSON subset of JavaScript, he was afraid that people would use comments to specify some instructions to the recipient of the serialized data and how to understand things. So, for example, there is no date type in JSON, so you would have to represent the date as a string or as a list of numbers, and you might want to put in a comment there to the recipient saying, "Oh, this string is supposed to be understood as a date." But that's dangerous, because if you have comments, then of course comments shouldn't matter. You should be allowed to strip comments, minimize your code, and everything means the same. And so comments wouldn't round trip. However, JSON 5 is more geared towards being a config file format, and there we can allow using comments. And so there are two types of comments you can put in. You can have 2 leading slashes, so that makes an end-of-line comment, just like you do with the lamp in APL. And you can write an inline comment, so that's a comment that ends by writing /* and then ends with */. This is like exactly like in JavaScript and C and many other languages do it like this. This means you can use the multi-line comments to comment out entire blocks of your configuration file. Then there's a nice convenience. JSON doesn't allow you to continue a string, a text, on the next line. This means if you don't have an editor or a viewer that wraps the text in a way that's pleasant to look at, you might get stuck with something that's very hard to read or very warped. JSON 5 allows you to escape, so it uses the / as escape character, escape the line breaks, and that just means that line break is ignored. And this gives you more freedom in laying out your file the way you want and restricting line lengths if that's something you want. Another convenience is, while JSON only uses double quotes for text, JSON 5 also allows you to use single quotes. And that means if you have some double quotes in there, which could often happen, say if you are having generating some HTML and you have some attributes, and the attributes are in double quotes, then JSON 5 allows using single quotes, so you don't have to escape the double quotes. Other than that, the 2 types of strings are completely identical, and all the escapes work the same. Then for what I think at least is the most important feature, and also the visually smallest one, the trailing comma. Trailing comma is important. The way it works in JSON is that when you have multiple name-value pairs in an object, or you have elements of a list, they have to be separated by comma. JSON 5 allows you to put a comma after every element or after every name-value pair. And when this becomes really important is when you add another element or another name-value pair. It's very easy for humans to miss that they have to go back and add another comma in front of that. Furthermore, if you're using version control systems, they usually treat files in a line-by-line basis. So this means if you have to go in and you put a comma on the previous line, it will look as if you modify 2 lines, when in fact you only added one single entry. And the line above that was marked as being changed, you didn't actually make any meaningful change to that. Now you might say, well, we can solve this by putting a comma in front of every element, or in front of every name value pair. But firstly, that looks really awkward. And secondly, if you ever wanted to add something at the beginning of an array, or at the top of a list of name value pairs in the namespace, then you would have the same problem of having to add a comma on the next one, and you would again affect 2 lines when really you only wanted to insert one. And we can see that even in arrays, trailing, it might not look so lean like this, and you don't have to do it, but you are allowed to add a comma at the end of an array as well. Of course, we have updated the syntax color that was able to color JSON, so it can handle JSON 5 as well, not erroring on the things that would otherwise be illegal in JSON. What about the other way? Now we've been dealing with writing JSON 5, but we can actually generate JSON 5 as well. Of course, since all JSON is valid JSON 5, we could have gone with just generating the same thing and never worrying about outputting something different. But it's actually nicer to read JSON 5. So if you want that, you can turn it on, and we will generate something that takes some allowances and to generate something that looks better. So here's some traditional APL code to generate a namespace. Inside the namespace, populate it with some things. And here we've told APL to generate plain old JSON from that. And we can see it's quite noisy with all the quotation marks everywhere. Switching to JSON 5, the quotation marks mostly went away. It automatically switches to single quotation marks if that's beneficial. We can see that we're still keeping the quotation marks around the delta 911, and that's because delta is an unusual character. And we can see we got a shorter escape form, just 2 hexadecimal digits, and we added the commas at the end. So a lot more noise in the JSON, and a lot cleaner in the JSON 5. Actually, in version 19, we're going to start writing an even shorter escape form that's allowed in JSON 5 instead of the general 2-digit one. That's just for this one character, the vertical tab. It's not very common. Moving on, quad R and quad S. Quad R and quad S are very versatile, but sometimes they can be annoying in being too powerful when that's not what you want. So let me illustrate this with a use case for it. Let's say you've been tasked with writing a multi-million-dollar system. The specification is a dyadic function, and it takes a template text as right argument, and then it takes the name of a legal entity, a company, as left argument. And then it does sort of a mail merge. So it takes this tag and inserts it in the right and replaces it everywhere with the name of the company. And it just works. Hooray for bug-free programming. And you deliver this to your customer under much fanfare, and they're very happy about it, and a couple of weeks go by, and then they call you up and they say, well, so we have one of our customers, they have this fairly normal name, but when I try running your system, it doesn't work. It's broken. What happened? So wave goodbye to the bug-free programming. What's going on here? And then you realize, of course, we are using an ampersand. Ampersand has special meaning in replacement format. It means the match itself. So we're replacing the tag with something that contains the tag itself. That's no good. But we can fix this, not to worry. We'll just escape the ampersand. How do we do that? Well, we just have to put a backslash in front of it. And what's better for replacing text or changing text than quad R? The only problem is backslash also has special meaning. So we have to escape the backslash and escape the ampersand. That's a lot of backslashes, but it works. We send off the hotfix to our customer, and they're happy, and it works. Then a couple of months go by, and they call you up in the middle of the night, and they say, oh no, this is hip new company. They call themselves backslash, and they break your system. Oh dear, what's going on here? This is a bit obscure. Turns out, of course, that backslash is also a special character in the substitution pattern. So now we have to go into the documentation of quad R and find all the characters that have special meaning and make sure to escape all of them. This is getting uglier. But we send it off to the customer, and they're happy, and even the backslash companies can get their mail merges done. One day, they call you up, and they say, you know what, we're really happy about the system. Would it be possible to add a feature? You see, we're not entirely happy with this tag we have to insert. You know, sometimes we're dealing with percentages and numbers, and it's confusing. We've created a global variable, and it holds the value of the tag. Could you modify, of course, against payment of another few million, your code so that you can just use this global variable as the tag instead of having it hard-coded? Of course, you say, that's not a problem. Easy peasy. We replace the hard-coded value with the name of the global variable. And it's great, except it doesn't work. Now it didn't do anything. And then you remember, of course, $sign has special meaning in the left operand of quad R. In the search pattern, it means the end of a block. And any characters following the end of the block doesn't make any sense. That will never match anything. And so nothing happens. Okay, this is not fun anymore, but now you're ripping hair out. So we take a good and hard look into the documentation on quad R and of the Perl-compatible irregular expressions. And we find something we can use. There's something called quoting and end of quoting. And so it turns out between anything begins with \q and ends with \e, all special characters are considered as the normal value. They don't take on the regular expression meaning. This is exactly what we need. Great. And this works. Oh, now we can use whatever pattern they want. And then a year passes by, and you mostly forget about this system. And then they call you up and say, hey, you know, we decided on using backslashes. And now your system doesn't work. This one is really obscure. Even looking through the documentation won't give this one away. You have to be another Sherlock Holmes here to notice what's going on. So after much ripping hair out, you find that it's of course the \e in this pattern is interfering with the \e in that ends this quotation system. And that means that the trailing slash is going to be taken as an escape slash for the next thing. That's a slash before the final e. And it comes out that we are looking for this completely garbled pattern. Okay, no more hair left on the head, but now we have to really think what to do. So we read through the enormous amount of documentation for quad R, and we find that we are allowed to escape any character which is not a word character, and then it just takes on its normal meaning. And anything that's a letter or a digit, they can stay the way they are. So we can apply quad R to any non-word character, that's what the capital W means, and put in a \, which has to be escaped, of course, before that. And this isn't fun anymore. Our beautiful system became so ugly We can't even bear to look at it. And that's why I'm happy to announce to you that with version 18, we have a much better way of doing this. So while this works, and can work in older versions, it's much neater to simply turn off the regex. So the regex option says regexes should be off. By default, they're on with a 1. In fact, I won't show it here, but you can experiment with this. If you give it a 2-element value, then you can turn on or off the regex system for the left and right operands separately. Remember that during all this, you're allowed to ask questions in the chat, and Richard Park is sitting in standby to forward me any questions. Meanwhile, I'll continue. A bonus feature. So, as I said, there's so much new in 18 that we actually forgot about some things. Quad R and Quad S have been enhanced with the ability to case fold, just like we had case folding added as a new system function. Just to let you remember this, case folding, that is when we do a transformation of some text to allow computers to compare the text. Case mapping, that is when we change the visual form of text so that humans find it pleasant to look at. If you want the full details of that and lots of examples of it, go to dialog.tv/webinar and look for the first part of my series on the language features of version 18. For now, let's just go back in time a little bit and have a look at what was in that webinar. This is Quad C doing a case fold on some Greek text and also doing some case mapping to lowercase of the same text. And the difference, which is highlighted here, is that the final sigma, which has 2 different forms in Greek, it gets normalized when we fold so that it compares to other sigmas correctly. Where in mapping, we want to preserve the special final form of any letters, because that's how it's supposed to be for humans. We're just changing the letters to lowercase. With that out of the way, we have had since the beginning of Quad R and Quad S, we had the ability to lowercase or uppercase matches. The new feature here is that we allow you to fold it. And so if you compare them again, we can see that folding the match, that changed the sigma to a normalized sigma, whereas lowercasing didn't do that. So you might ask, so we have a one-to-one correspondence between this addition to Quad R, the addition to Quad S, and the additional new function with Quad C. That might cause you to ask, why do we even need this? We already have Quad C, and Quad R and Quad S could just use Quad C. You could do whatever you need to search for, and then you could apply Quad C to the result. And that's true, but there are cases where that would be either impossible or very awkward. A good example of that is actually a feature I think many people don't know about with Quad R and Quad S. They're able to process files directly without first getting all the file content into the workspace. So if you tie 2 files, so here we have an input file with tie number 1 and an output file with tie number 2, we can actually go through block by block and process the file, the input file, and as we go through it, we create and append to the output file. And this allows us to process a file that's much bigger than our workspace. If you were to use Quad C for this, then we would have to manually go in and read blocks of the text and apply Quad C and then spool that out to a file and then continue, because it couldn't fit into the workspace all at once. Another reason for it might be if you only want to fold certain parts that we find. For example, we could have a system with some names that need to be normalized, but there are also some character codes that we don't want normalized because uppercase and lowercase actually has meaning. I'm not going to show an example of that because that would make it for quite a verbose example, but here's a practical example where it's at least convenient to use the new case folding functionality of Quad R and Quad S. So we have a couple of names that somebody has entered into our system, and we try to compare them. And even though we do so caselessly by normalizing the case folding first, they still don't compare. And if we look at what quad C did, we can see that, of course, there's a comma in one of them and the other one doesn't. So we want to mangle text like this. This is a prime example of where regular expressions come in. So we can write a regular expression like this. And what we have here is a sequence of word characters. That's what the W stands for. So those are letters. Then some non-word characters. The uppercase W means not word characters. And another sequence of word characters. In effect, these are two words separated. And the parentheses, they number our groups. And that becomes our group 1 and group 2 over in the transformation format. So this means we take group 1 and we fold it, we put a space, and we take group 2 and fold that as well. And then because we're dealing with Greek text, we have to tell quad S that we want Unicode character classes to be included in the normal character classes. Otherwise, the word characters would only be ASCII word characters. And now we can apply the normalization, and you can see we got rid of the comma, and we also folded at the same time in one go. And now we can compare them, and they're equal to each other. Feel free to ask any questions in the chat, and I'll be available to answer them. The final thing for today is a very niche thing, but it can be very annoying if you bump into this. It is most likely that you won't have to deal with it, but it is handy if you need it. Let's say that you have imported or created some data, you want to generate an HTML document, and you have used character turns as line breaks. Yes, I know that's unusual, but that's exactly what's going on here, that we have enhanced quad input to deal with this unusual case. There could be various reasons why you have settled on character turn as the separator. Now, in order to be fully standards compliant, HTML documents actually need character turn line feed as the line separator. So we're telling quad input we want this content. We don't care about a byte order marker, but we do want 1310, that's character turn line feed, as the line breaks. However, if we then go and see what did quad input actually create, we will be disappointed, because we'll see that it used the character turns that we had in our original data. What's going on here is that quad input is primarily geared to deal with text files, and upon getting text files in with quad nget, we will normalize line endings to line feeds. So quad input also expects by default that you're using either a nested vector or that you're using line feeds. And so it will obey your setting for whatever line endings you want on output, but it will only convert instances of line feed because that's what it expects. And any other types of line breaks, they will be put into the file in a raw manner. And that's why we have added this option. NEOL means normalize end of lines. And normal setting, the default setting is 1, which means that we are going to create a file according to the line break that you have specified, but only when we see normalized line endings. So that's line feeds. You yank it up to 2, then it takes all line break characters and convert them to whatever you have specified. And so again, unlikely to happen, but very convenient if you need this. That's what I wanted to go through today. All the improved quad names, system functions, system operators, including the bonus feature. I will continue in 4 weeks with the remaining ones of all these new things in version 18. In 2 weeks, Richard Park is going to do a webinar where he goes into depth on the rank operator. You can join us then. Be aware that next week's British APL Association webinar is cancelled due to vacation. So the next webinar will be the Dialog webinar in 2 weeks with Richard Park. Thank you so much for watching.